So a while ago I was working on a project that used TypeScript and Express, and at some point I got surprised to notice that I was getting autocompletion for the request params that I had declared in the route path. So what I'm talking about is that if I query the request params object, as you can see, I'm getting the request params that I've just declared above, which are in this case class ID and foo. In this video I would like to walk you through the process of discovering how that works, and hopefully at the end I'll be able to share some new learnings. Alright, I guess the best place to start is from the definition of the get method. It will take us to several places, but we are going to start from here. And if we go to the definition of this interface, here we can see that route is a string, and this will in essence be the type for the first argument, which is a path, which is the string path that we provide to the method, to any of these methods. And the second type is the one that that represents our focus for now, which, as you can see here, this type will map to the route parameters, which are determined from the route, which is again a simple string. Okay, let's see how the definition for route parameters look like. I think it would be a wise idea to bring this string closer, because we are going to reference it quite a lot. Right, so from this definition, and by the way, this type is where the magic happens. This is the reason as to why the behavior I was talking about in the beginning works. Let's see what we have. We have, first of all, route, which it says that it extends a string, which is expected. But then an interesting check appears, which is string extends route. So at first, when I saw it for the first time, I got a bit confused, because if route extends string, then seeing the check string extends route looked a bit weird for me. But then I thought that the type string is very generic, but from this type you can derive other types. I can think of only one at this point, but that type is the constant string. So if I were to add this const name is Andre, the type of Andre will be the type of name will be the constant string Andre. However, if I change let to const, const to let, then the type of name will be a string. So name can be any string right now. I can change this value very easily. But if it is const, then the value of the type of name can only be the constant string name, because name cannot get any other value than the current one. So basically this is what this check is for. It checks if route is a constant string, and there's, by the way, another way to provide a constant string, which is by directly providing that string to the method as an argument. So in this case, this string will be a constant string. Okay, so if that check is true, meaning once again, if route is a constant string, then it will go to the next branch. But since we don't have any left parentheses in our string here above, then it will go to the next branch. And here is where the interesting stuff takes place. So as you can see here, it is used a very, I would say, interesting feature of TypeScript, which is called template literal types. Is basically an extension of template literals in JavaScript, but as you can see in this case, it allows us to match certain patterns in strings. So in this case, it will check if the route string that we have provided is of this contains this pattern, which says that at some point there is a colon, then before the colon there is a string, and after the colon there is also something which will be inferred, which means that if it is inferred, then it will be used afterwards, as we will see. So in this case, rest will be exactly what's after the first colon, which is that string that I've just highlighted here. Then what happens if we go step by step? We go to get route parameter, and here we encounter another type, which is remove tail. And for example, let's take this one here, because this is the first call. As you probably noticed, there are some nested calls for the same type, remove tail. And this one that's highlighted, it will remove from a given string the slash that follows it, or to be more precise, it will remove the ending part that starts with a slash and has any string after it. So I'm sorry, at this in this situation, it will remove basically this part here from the string that we had initially. So the current string we are talking about is this one, and what that type will do is to remove basically this part here. Just a moment to get my Vim keystrokes right. So that remove tail will remove this part here, and we will be left off with class ID. And basically this is what this type get route parameter will do. Okay, so if we get anything from this get route parameter, we'll go to the next step, which is to check if this class ID request parameters is optional. So for example, you could have something like this, but it isn't the case. So we will go to the next step, to the next branch, which is this one. And as you can see, this type, this part here, this the content of this parenthesis will return an object whose only key will be the route parameter that has just been resolved, and its value type, and the value of this key will be a string. The type of the value will be a string. Now we are almost at the end, but there is one more thing we have to do, is to check if the string contains other request parameters, and this is what is achieved with this part, with this line here. So what we'll do at this point, so we are left with this string because this is the rest part. So rest will be, so the rest I'm talking about is this one here. Okay, and at this point, at this line, it will check if rest. Okay, so basically what this part will do, what this part here will do until the bracket. So this highlighted part will essentially extract the class ID from here, this one. It will extract this in order to see what's next, and at this point, next will be this part here, full, average, and that's it basically. And what happens next is that we will call the route parameters type will be called once again for this string here. And as you can probably see, there is a recursive manner that keeps on taking place until there are no more route parameters. So in the end, this route parameters type will return an object, which is very, I would say, cleverly written, so that it can determine so that in the end it can return an object that contains all of the route parameters and basically their types, which is for all of them the string. Yes, that's it. It was an interesting discovery for me, and I guess I will see you in the next one.